Friction depends upon the nature of the surface. We can prove this with the help of an activity. Make an inclined plane on a smooth floor or a table. Put a mark with a pen at any point A on the inclined plane. Now let the pencil cell move down from point A. How far does it move on the table before coming to rest? Note down the distance. Now spread a piece of cloth over the table. Make sure that there is no wrinkle on the cloth. Now again let the pencil cell move down from point A. How far does it move on the tablecloth before coming to rest? Note down the distance covered. In both the case, we observe a change. In first case, the pencil cell cover more distance compared to the second cell. So this shows that the frictional force depends on the nature of surface. Surface irregularity. All surfaces, when zoomed into a microscopic level, contain hills and valleys that interlock when they move on or rub on top of each other. This unevenness of the surface is called as surface irregularities or roughness. Rough surfaces have large irregularities while smoother surfaces have less irregularities. Irregularities on the two surfaces lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. On rough surface, there are a large number of irregularities, so the force of friction is greater if rough surface is involved. The force of friction increases between two surfaces if they are pressed hard, and hence the movement of the object becomes restricted. However, if there is no pressure on the object, can easily move. For example, if we want to drag a mat when nobody is sitting on it, we can easily drag it. On the other hand, when a person is sitting on it, we have to apply more force compared to first case. Static friction. The frictional force that comes into play until an object starts moving is called static friction. An object has to overcome the static friction in order to start its movement. So we can define static friction as the force required to overcome friction at the instant an object starts moving from rest is measure of static friction. Sliding friction. Sliding friction comes into play whenever an object moves along the surface of another object. Such a movement is called sliding friction. On the other hand, we can say that the force required to keep the object moving with the same speed is a measure of sliding friction. When the box starts sliding, the contact points on its surface do not get enough time to lock into the contact point of the floor. So, the sliding friction is slightly smaller than the static friction.